Okay. Yeah. Hi, everyone. Welcome to the first live panel for the VQA workshop. I am Ayush Srivastav. I just finished my master's from Georgia Tech and will start my PhD at University of Michigan this fall. I will be moderating this panel today. Before we proceed, a few quick notes. We will be recording this panel so that those who couldn't join us due to time zone differences and such can watch it later. We will be posting these recorded panels on our external website. Everyone except panelists, please keep yourself muted. Panelists, please feel free to interrupt or speak at any point. We encourage the audience members to ask questions. This is your opportunity to interact with the speakers. In order to ask questions, please either type the question or mention that you have a question in the chat box and we will call your names in a sequential fashion. You can then unmute yourself and ask the question to the panelists. It would be great if folks can keep their videos on if they are comfortable. So let's get started. We have 5 panelists in this session. All of them are also invited speakers at the workshop. If you haven't watched theirs, if you haven't watched their talks already, please do so to learn more about their work. So today on the panel, we are excited to have Vittorio Ferrari, who is a senior staff research scientist at Google, where he leads a research group on visual learning. He is also an honorary professor at the University of Edinburgh. His research currently focuses on learning visual models with little human supervision and 3D deep learning. In his talk, Vittorio talked about connecting vision in language with localized narratives and open images. Then we have Raquel Fernandez, who is an associate professor at the University of Amsterdam, where she leads the dialogue modeling group. Her research is at the interface of computational linguistics, cognitive modeling, and artificial intelligence. In her talk, Raquel spoke about visual and conversational salience. Then we have Aida Namatzade, who is a staff research scientist at DeepMind. Her research interests are at the intersection of computational linguistics, cognitive science, and machine learning. In her talk, Aida talked about multimodal pre-training. Then we have Damia Tene, who is a research scientist heading the machine learning group at IDEAP Research Institute in Switzerland. His work is at the intersection of computer vision, natural language processing, and machine learning. In his talk, Damien spoke about the limits of statistical learning in VQA. And finally, we have Olga Raskovsky, who is an assistant professor in the Department of Computer Science at Princeton University. Her primary research area is computer vision, closely integrated with machine learning, HCI, fairness, accountability, and transparency. In her talk, Olga spoke about models, metrics, tasks, and fairness in vision language. So let's get started. So yeah, from the audience, does anybody want to start with the first question? Oh, so Shashank in the chat has posted that I have a question for Olga. For your image captioning bias project, Dora, Dora mentioned that the ground truth data itself is biased. Do you have any thoughts on what measures we can take to reduce the bias in the data collection process?
Well, I think thanks very much for the question. At a high level, I think first of all, just asking these questions is part of the way there. Just kind of being aware of this and realizing that we need to take these steps and asking these questions about your data sets. I will do a shameless plug for Revise, which is a tool that we recently built to try to reveal bias in data sets, and we didn't talk about it in this talk, but this is I'll actually post it in the I can post a link in the chat, but it's a tool that we built recently that basically takes in your images as well as like whatever annotations are available for it. So if you have object annotations, we'll use it. If you have gender or skin tone or whatever annotations, we'll use it. If you have GPS labels, we'll use that, and it'll essentially output a bunch of graphs. It's kind of similar to if you're familiar with like Derek Hoem's work from 2012 on like diagnosing errors in object detection, kind of that style where it'll sort of print out a bunch of graphs for you to examine and analyze and see what kind of biases it might find in your data set. And then we do some effort to propose, constructive solutions, but they're kind of the form, maybe query for more, more of a particular type of image to augment your data set. So I'll post the link in a second, but yeah, there's more and more kind of tools out there that are needed for large scale data to try to understand the bias and then fix it.
Does anybody want to add anything to this? Or if not, we can go with the next question.
Actually, I have a related follow-up question, and this may be broadened to everyone on the panel, not just Olga. Since the previous question was about bias in data sets, which is something that the community generally has talked about a lot, and we presumably have begun to take seriously. One trend I've noticed, and I presume all of you have noticed, is that as a countermeasure to fixing the bias problems, there are now increasingly data sets that are just never released. So there are just in-house data sets, like the one that just at the top of my mind, the one that CLIP was trained on, 400 million image sentence pairs and so on. Since this is a panel on future directions, I was wondering if the panelists had thought on, is that the future for example, tasks and data sets where the data sets are just never released?
Are we supposed to ask the moderator for a word? Or what's the process? So the process is that I spoke first, so I answer. So, well, I sure hope not. Please be wrong, Drew. If we, without releasing, then people have their own magic sauce at home. Actually, it's more than sauce. They have their own magic engine, because we all know data is as important as the model itself. And that would be really hampering the progress of us as a community. So hopefully not. But I also, working at Google, do realize the pressure there is when you release publicly, and if you get attacked too much, then of course you might lose a bit the motivation to. So it's a big societal balance we face into managing to put enough pressure on researchers and dataset acquisitors to try to mitigate bias and at least document the bias that's in the dataset without discouraging publication. It's not so easy. One thing that I think could be a solution is that we managed to remove, the pressure and the shame by asking publisher. This is something I was thinking of doing for open images, for example, by asking those that publish to release a self-assessed bias acknowledgement. For instance, we just published, shameless plug on my end, just published a paper on IS on gender bias and age bias on open images. And we tried to rectify it with an extension. We did such an analysis, and it didn't take that much time to figure it out. Then, of course, Olga was talking about regional biases as well in her talk, and there are plenty of other kind of bias. But it would be acceptable, in my opinion, to ask dataset makers to not necessarily fix it, because it's a lot of work, but at least provide a few charts, so it's distributed this way across certain bias directions. That would already be good progress, with raise awareness, stimulate finding solutions. Anyway, that's my middle ground.
Ayush, do you want to go through the, yeah.
Is this the work, Rito, that you were mentioning?
So I wish I could I need to open it in a new tab, and then it tells me, oh, you're leaving Zoom, danger.
Oh, I see.
That's the one. Yes, that's the one. Oh, thank
awesome.
you.
Thanks.
Thank you, Olga. That's the paper.
Awesome. Since Peter was talking, maybe I have a few questions that I can direct towards him based on his talk, if that's okay. So in your talk, you mentioned that like the localized narratives scale well. I'm curious to know if you have comparisons between what the cost would be to get equivalent annotations using the traditional methods versus actually letting the users speak and then browse through the mouse point.
So I'm not sure I catch the detail of the question, but the traditional method would be only typing a caption without simultaneously moving the mouse and speaking. So I do have some quality, I could pull out numbers from the top, but the general impression, let's build the hierarchy. So if you just want the text, not the mouse trace, talking is immensely faster than typing. So out of the top of my head was something like 3 times or so. And also when talking, it's much easier to convince people to produce long and rich captions that describe relationships and attributes. It's easier to tell your annotators, just tell me everything about the image. That's also why localized narrative captions are so much longer than standard. Now, so that's clear. Now, if you want the mouse trace, it comes almost for free. So we did head-to-head tries with the rated just talk or talk and a mouse trace. That's only maybe 10-20% slower. So that's cheap. Now, that's if you are ready to transcribe from speech, but that will have errors. So the way we did actually localized narratives is that we asked annotators to transcribe afterwards. And that's a little faster than captioning because you don't need to think, but still the total sum cost exceeds slightly the cost of just typing in standard captioning. So when we said it scales, we meant it's easy to teach the annotators, it's not that expensive, you're still in the same kind of ballpark as typing a caption from scratch, and that's why we managed to make it big. So it's a complicated answer, but
I was just, I understand that there's no free lunch. I think it's really cool to have that kind of a data. I think a future possible extension question is like, how do you envision this framework to scale for videos? So like we imagine videos to potentially become a more ubiquitous media in future. So I was wondering if you had thoughts about it, or is it kind of limited to images at this point?
a lot of people have asked us over the course of, it's about over a year that we published the data. Can we do this on video? It would be awesome. And there are a few attempts within Google. People have tried a few things. So the fundamental knot why I cannot tell you, okay, we nailed it, this is the interface, because I don't have that answer. We tried a lot of prototypes. The fundamental problem is that there is a dissonance or a competition between two desired goals. The goal of doing it while the video is going to preserve naturalness, because we see it's natural. That's why you get beautiful caption. But at the same time, we want exhaustiveness. We want people to talk about everything. So that it's a fundamental trade-off. If you let the video go, people will focus on the main object. We did tons of experiments on that. They will say, oh, the car is going around, and they will forget the bird in the background. And if we ask them stop and go back and then describe, so we had a lot of trouble getting our annotators to comply to such a guideline. They just don't like it. And even if they would, then it's a lot of trouble to integrate the whole thing into a nice narrative. So I'm not saying it can't be done. It can be done. There are very, very interesting things like video saliency things that detect automatically, human-machine collaboration style, and they stop the video when something changed, and then they let you talk. There are many ways, but to be honest, I'm not today ready to tell you, okay, we nailed it. This is how we do video localized narratives. It will be fun.
Yeah, makes sense. Yeah, thanks a lot for your answer.
I have a follow-up on that. That sounds like an interesting trade-off. And I'm wondering if you play the video in super slow motion where people just don't, like, they talk about the car and now there's nothing else to talk about. So they talk about the birds. And I wonder if that would help, but just because it's so, you can talk much faster. And if the video is going slowly, you will just say more and you might end up covering more things while still being natural. You may have already tried this, but I'm curious what you think.
No, that's a good idea, and it does work. Actually, the extension to this idea, which is dynamic time. So you say you play the whole thing at uniform low speed. So what we found it's reasonable is to let it go at normal speed and then let spacebar stops the video, and then they talk a bit, and then so all around the spectrum are all things that will lead to some reasonable results. Yes.
Does anybody want to add anything? If not, we can move to the next question. So Harsh has posted a question in the chat. Harsh, feel free to ask if you want. Otherwise, I can sort of say. So this is the question for the panel. Most state-of-the-art methods on challenges like VQA are pre-trained on massive data sets scraped from the web. But all the test sets are sampled from the web as well. isn't it quite possible that pre-training data sets and test sets have overlap? Should we as a community be more careful or have guidance on which data sets are okay to pre-train on?
I think the answer is clearly yes. I think the question is, the short answer is yes, we should be. Ada, I saw you were unmuting yourself as I started to speak.
Oh, please, finish your thought. I can go next. Yes, okay. No, I was just gonna actually ask, is this really the case that people, so the work that I know that evaluates on VQA, people are careful, but in checking whether their pre-training data does include data from tests. I think for the very recent models that maybe are something like CLIP, if you test it on VQA, that might be an issue. There are ways that we can test whether the pre-training data matches the test data by basically comparing image similarity or language similarity. And I think people are really, at least work that I know, a lot of people think about this, they do try to deduplicate the pre-training data. It gets harder as we train on larger pre-training data sets, but I think it's an important consideration. Basically, we have to make sure that our test data, at least test in domain generalization.
Okay, so if there's nothing else to add, oh, there you were, sorry, you were saying something.
I was just going to say that it also gets tricky when people have released pre-trained models, but not the data set, right? So for CLIP, for example, there are some models that have been released, but the data set isn't. And so, yeah, that wouldn't, going back to Dhruv's point and the discussion with Vito, that makes it tricky. Yeah.
I was also reminded of a little analysis that Ross had done in his RCNN paper. He had actually calculated, I think, duplicates between or overlap between ImageNet or IL SVRC 12 and Pascal, and it was less than 0.6% or something. He was basically trying to establish that it's not that pre-training on ImageNet gives you an unfair advantage. So I can imagine techniques like that, just sort of check for duplicates, check for near matches, and you can, I wonder if anybody's done that analysis on some of the conceptual captions versus other data sets.
So just to add to this, I think that the community is automatically emerging guidelines of good behavior in this respect. For example, the Dino paper by Facebook, do I say right? It was extraordinarily large pre-training set, and they have a very nice section on how it overlaps with the downstream tasks within the target task and the test sets. And I think the same happened to Uniter. I have to think exactly, I read so many papers, but the general trend, it was certainly in the Dino paper, the general trend these days is to do such a near duplicate, not removal, but near duplicate analysis. And often it turns out that the training, so that the target test sets only contain, less than 1%. Less than 1% of them is contained in the large pre-training. So I think that it's nice that it's self-policed. The community has this instinct, and I think we are going the right way already.
Okay, so yeah, so we can move on to the next question. So Ashwarya has a question. Do you want to ask?
Yeah. Hi, everyone. Since we are talking about pre-training data, I have a question related to that. So it seems like the performance we achieve in our vision and language models is sort of upper bounded by the data it is trained or pre-trained on. And this has been highlighted by many of you in your talks as well in various different ways. So I'm wondering, how should we think about solving vision and language in the context of being upper bounded by the data that we are training on? So one way to think about it would be collect as large and as varied of a data set as we can, so as to approximate the true distribution of data in the world. But that sounds like a very expensive, time consuming, and not a well-defined task. So what are the different ways in which we can still solve vision and language without solving the data collection problem first? And I would like to hear each of your thoughts on this.
Was a particular of us asked?
Should I mute?
I think she meant broadly at the panel, not a specific.
At the panel, let's have some other panelists go first this time.
Yeah, I said I want to hear all of your thoughts about this. Whoever wants to go first can go first.
Maybe I can go first. I think one of the solutions could be to have a model be able, well, give it the possibility to acquire the required data at test time. So I guess if we cannot include everything that we need at training time, we could at least train the model to be able to look for itself for whatever information is needed at test time. So I think that ties to continual learning and those approaches where you train an initial model, but you allow it to grow as needed with new information.
I was also wondering what you mean by solving language and vision.
Just like what we mean by solving AGI, except like AGI has a bunch of things. So the perception component and the communication component of AGI, I guess.
I think language is relevant for this issue because language is evolving. So we have new terms, new words appearing all the time. So I guess vision language is actually a good test bed for this kind of scenarios where you actually need to update the model as time goes on.
Right, but I guess that my clarification question was more related to the fact that maybe we cannot think in such general terms, right? And that maybe we need to break down problems and think about specific data for those problems. Maybe you then will have the issue of wanting to put things back together, and how do you do that, right? So of course we have that, but I find it a bit too overwhelming if my goal is let's solve vision and language. I don't know where to start.
Maybe to add to that, I think there's still a lot of progress we can make by just thinking about better models. And even in the larger scale models that we've seen recently, one interesting observation is that like this, we can go very large if you have dual encoder architectures, models like CLIP, but they still do similarly to a model like Uniter, which is small and way smaller data sets. So it seems to me that like, although we always see some progress by just increasing the size of the data set, and this is something I think Damien also mentioned in his talk, which is interesting. Like if you think about associative learning or like learning associations, larger data sets are useful. But if you really are interested in types of generalizations that people do or just auto distribution generalization, I think thinking about better models or like what types of modeling improvement we can make is the way to go. And that doesn't really require us to probably, for the existing tasks, we probably don't need as much more data sets as we have. We can just think about how to use them in a better way with better models.
Olga and Vito, do you want to add?
So it's tricky because I like the way the question was phrased. We need to solve the data problem first before we can solve some reasonably large class of vision and language problems. So, it's very tricky because of course we will always be as a community swinging a pendulum of we are eager to solve and move forward the data we have, but then we stop, we realize we don't have the right data, and we spend 3 years building. It's tricky. So I will be humble and at least cut out a piece that I think we can never get rid of, and that's proper evaluation sets. So solving all of the training data problems, debias, and have them maybe with the right properties that don't lead you to find spurious correlations, like Damien was saying in his talk. That will be tough and maybe will take us forever. but maybe it's possible to do super self-supervised. But the evaluation sets, those are like, really, this is the cornerstone of what makes us a science. We have to be able to state we solve this problem to this degree because we have a reliable test. And even creating very good test sets is a lot of work. So I would say, no, we are not going to solve vision or language or anything before we solve the data problem, in the sense that we need to at least solve how to build test sets correctly. So it's a limited scope answer, but that we really need to keep in mind.
I think we can move on to the next question.
Hello, I had a question quite relevant to this discussion. It was actually, it is more for Damien. Like he in his talk mentioned that we need to induce these causal structures in our VQA models so that they understand causation and so on. And the way we can do this is, as he goes on, is by augmenting more data, either counterfactual or doing some changes into that. So is there a way to do this by changing architectures as other people touched upon, rather than by changing the data itself? Like, do you have thoughts on that?
I think the fundamental point that I was trying to make in my talk is that we need different training signals, and sometimes the training signals are available in some data sets in the form of some meta annotation, or sometimes we can recover some information by clustering the data, but we need to inject then some task-specific knowledge or some knowledge about how the data was collected. So there's just no free lunch. So you need to put something else in. Just learning from ID examples, just learning correlations, then that runs the risk of learning spurious correlations. That's what we want to avoid. But to solve that, we have to put something in, some knowledge about the task, about the data set, the data collection process, and or additional training signals. I think sometimes we do inject some task-specific knowledge that's helping in the form of architectures, just by injecting some inductive biases that are relevant for the task. Sometimes we do that unknowingly by just trying architecture at random until it works a bit better in some data sets. But it works because we do inject something that's relevant for a specific task or data set.
Yeah, so let's move to the next question. So Shashank has a question. Do you want to go ahead, Shashank?
Yeah, I have a question for Ida. So when we have images with captions of the thought, subject, verb, and object, intuitively identifying both subject and object from an image feels like the same level of difficulty. However, in your experiments, you have pointed out that MMTs are much better at identifying objects than identifying subjects. Do you have an intuition on why this is the case? Is this artifact of that particular data set, or is it something much more than that going on?
Yeah, I think it's probably both. So the types of objects we get in the data sets are a bit more diverse than subjects in general. The subjects so we collected the data set that I talk about as real props based on conceptual captions. And a lot of the subjects in that data set are like person, and then there are some animals. And it might be that because of just the distribution, it was slightly different. For the things that we controlled, there was some observations that we talk about in the paper based on the similarity of the subjects in the positives to negatives. If we measure similarity using like a word representation where we use word to vector representations. But other than that, like for things like frequency or like other types of like things that could be a confound, there was really no difference. That was the only main difference between subjects and objects.
Thank you.
Sure.
Yeah. Okay. So let's move to the next question. Yash, did you have a question in general, or was that the previous one that you had asked?
Oh, I just asked it. Yeah, the same one.
Good. Yeah. Okay. So the next question that we have on chat is from Bo Yang Albert Lee. He asks, can Dr. Ferrari and other members of the panel talk or speculate about the relative strengths of directly using the mouse trace or converting the trace to bounding boxes or semantic segmentations in a vision language task? For example, if we want to do controllable caption generation, would it be more effective to use the mouse trace or to convert to bounding boxes that are commonly used right now?
Well, the answer here is it depends what is the vision language target task. Like in our own original paper, we actually converted a trace to a pseudo segmentation map in order to do image generation from a combination of text and mouse traces on an empty canvas. So that worked better even than boxes. Or in the controlled captioning one, we turned them into boxes because it was easier to alter our Wilbert style models to incorporate boxes. Was easier to make box tokens and pass them through transformers. So in that sense, we did it that way for an engineering goal, right? And there might be plenty of other tasks that I don't know, referral exception resolution maybe requires another representation. So I'm not sure that there is a preferred strongest representation here. It's more about information content. The traces have a reasonably approximate, but informative grounding that tells you where a particular word occurs in the image, and that information is what drives the effort and what makes tasks easier, like controlled captioning. Then how exactly the representation that you then transform this information into depends also on the model you're using, on engineering comfort. I don't think there is an absolutely right answer here.
Thank you. Somehow my camera just stopped working, but thank you for the answer.
Yeah, so if yeah, we can go on to the next question if nobody has anything to add to this question. So the next question is, do you think learning causal reasoning mechanisms for vision in language might be only possible with an embodied AI that can interact with the world? Or do you think it is possible with regular data sets by collecting better data like counterfactual data?
I guess I'll take this one. So it's possible to do it by data that has been collected before, if you have some knowledge about how the data was collected. So if you instructed the annotators to come up with counterfactual situations, then that's totally fine. You don't need the AI, the model, to take itself the decision to interact with the world. If you have some knowledge about the data collection process, then you have something useful to use. Yeah. So I guess there's some room for innovation in the way we collect data, to collect data in some novel ways, some creative ways, to extract some signals from the annotators, or some stronger or different signals from the annotators.
Yeah. Does anybody have anything to add to this discussion? Okay, so yeah, so let's move on to the next question. So Boyang has a question. Feel free to.
Yeah, sorry, my camera doesn't work. But so we discussed the problem of data collection and whether data collection is necessary if we want to make big progress maybe in visual language. The obvious solution, or maybe the simplistic or naive answer to that is self-supervised learning, right, where you don't necessarily need a lot of human annotation. So I wonder what the panel think about that. Is that a viable path to solutions maybe eventually in vision language? Do you think perhaps the current self-supervised learning are maybe too focused on still some low-level semantic, or maybe is there a way that we could combine the existing data sets with some kind of self-supervised learning to achieve higher goals? that perhaps get us to semantic concepts that we haven't been able to get to so far.
Panelists, you should feel free to unmute yourself and answer the question if you want.
So just a clarification follow-up. Are you asking about like better ways to use the data we already have?
I'm asking in the context of self-supervised learning, right? So, representation learning that does not require human annotation, right? And we have a bunch of those in Vision. We have a bunch of those in language, like GPT, X, and there are a number of self-supervised ways to learn visual representations as well. So wonder if you guys think that that will be a viable path to solving some vision language problems, even though those may not necessarily be pre-trained on like a huge vision language data set.
Well, if I can,
yeah, go ahead, Olga.
Go ahead. I was just going to say, I mean, if I can jump in here, so I think it'll certainly be part of the answer, right? I think we're seeing, there's like a trend towards using more and more of different types of data kind of in different ways for different tasks, right? So there's like, 10 years ago, we were, arguing whether using an image and pre-trained model is fair game and fair comparison. Now that's kind of accepted as like the backbone for, whatever else you end up training on that. Now, though that is human labeled, but those human labels are not for the task at hand. Like it's, used as a backbone for in like vision and language things, but it's the labels are from a completely different task. There is certainly a lot of self-supervised learning that's helping learn better representations. In some cases, it's actually like directly useful for the task at hand. In some cases, it is used to learn kind of a knowledge of the world in a sense that then can be fine-tuned and improved for a particular task at hand. So I don't know if there is if you're asking, is there something that can be done with self-supervised learning that can't be done with supervised, then I don't think so. But there's also, there's definitely lots of opportunities to kind of bring everything together. And we're thinking more and more about like how to use all of these different sources of data towards particular goals and in different ways, and they'll all contribute sort of different things and different types of knowledge that's like easier to get from each of the different sources, if that makes sense. Yeah, sorry, Debbie, you were going to say something.
No, I was going to ask a clarifying question on the question. So yeah, I think what you said was more useful.
Actually, I'd say this is the present more than the future, no? I mean, the general scheme of we self-supervised representation learning on gigantic, 100 million whatever, data sets, and then fine-tuning for a specific, often actually vision and language task. I mean, I don't know, this seems to be Clip, Dino, Align, and Uniter, all that is, it depending on what you mean by self-supervision, but in the sense that data was already there, it wasn't annotated for a purpose, and you try to regenerate pieces of the data, let's say that's self-supervision. That's the present. That's more than half of the state of the art in a number of fields, including part of it, vision and language tasks, including captioning. And so I would say, yeah, I actually think the question, more than a question, I would say it's an advertising panel, what was asked. I don't want to say this is the way until the end of the universe, but it's definitely the way now.
One maybe additional thought on this, I think the self-supervision literature is very rich for the cases where we can actually think of data and how we can basically model invariance through data. And in the image models, we can now get very good results compared to the supervised models. But a lot of thinking, or maybe a lot of different types of supervision, comes from the modeler thinking what type of invariance we can model through changing the data such that we can help the model learn what is the invariance. But there's probably a limit to that. I think we have interesting predictive losses when we can use in the language modeling scenario for a self-supervised setting. But if the question is whether this is enough, I would say probably no, because again, there's a limit to how much we can build in this type of augmentations and losses. And they might be good for some tasks, but probably not for very general tasks or tasks that at least require reasoning.
So if there's nothing else to add, let's move on to the next question. So Ashwarya Kamath has posted a question. Do you think it is possible to solve fine-grained tasks like VQA, referring expressions, etc., using cross-encoder models trained at scale, like aligned clip scale data, without using object-level semantics or supervision?
My immediate reaction is define solve. So yes, it's possible to a degree. At some point, you will get to a point where just providing a few strongly supervised labels will get you much further than, collecting another million examples for self. So there's we can get part of the way there for sure with the self-supervision. At some point, we kind of reach a point where there becomes sort of this crossover point where just getting humans in the loop, getting them to provide a few additional labels will just be so much more effective than trying to further scale up self-supervision. And it's not, it's not immediate, it's not at the beginning of the training process, but we'll definitely get there. And so depending on what you mean by solve, I think to some degree, yes, but not all the way.
I guess what I meant by solve, I just find there's one set of models like dual encoder models, which are trained at scale, really big scale. And then, we have the rest of our Oscar, Uniter, etc., which are trained on VG conceptual captions, still much smaller. But they all kind of use object level semantics. And I guess my question was mainly about do you think we can just learn the same kind of information by just having huge batch sizes and having strong negative examples in your batch and learn that, suppose for a referring expression kind of example, you would need to know something is to the left of line wearing, a red t-shirt, and the difference between that and wearing a blue t-shirt, it's very fine grained, and object level semantics get you a lot of this information. But I'm wondering if you can get the same kind of results by just having these cross encoders, which hasn't been done yet because most of them are dual encoders. So yeah, having a similar kind of model, but trained at scale so that it can learn this kind of stuff. Or do we need objects always? That was the question.
Olga, did you want to add something or should I go?
You should go. I think my answer is, I definitely appreciate the clarification, but I think my answer is still similar. So yeah, you should go.
So to make it maybe a bit more concrete, I can tell you about one example of a task that I think requires fine-grained understanding, and it's the data set that we collected. Basically, all we were asking these models was whether they're able to distinguish between two images that are very similar, and the only thing that is different between the images is, for example, the verb. And the dual encoder architecture is not as great as the models that have cross-attention or multimodal attention. And you're right, we cannot really scale these multimodal models with the multimodal attentions like Uniter, Wilbur, that family of models. But one thing that we actually observed is that the limit there with the models that have cross attention is not that we cannot train them on larger data. is that the larger data sets that we have include noise. Basically, when we start scraping web and collecting data sets, automatically we have data sets where the image, just like image language pair, have some noise, meaning that the language in the pair doesn't necessarily describe the image. And this family of architecture is still not very robust to this type of noise. They will learn that the language corresponds to the image, or they learn these correlations that are not really meaningful because of the way we collect data. So if you collect a very large data set, which doesn't include any noise, and if you're able to scale these models, I think that's the best possible solution. But it's currently we cannot really scale these models as well. And again, I think my first thought is that we probably should think about how we can make these models, existing models, more robust to the noise that we get in the existing data sets, and then think about the scaling part.
Yeah, that was very insightful. Thank you. Good to know.
Maybe I can just conclude adding, I mean, in a way, it's connected to the answer before on whether the answer is solely self-supervision. You will, I mean, Olga was saying, well, at some point, you will need a few labels, maybe will bring you much farther than continuing to go self-supervised. It's a little bit more boring even than that, I would say. If you want to show that you solved or made a strong progress on a certain task, you anyway need to be able for the model to answer in a format that you can measure on the test set. And even if your model already knew everything about vision and language, you still need a few training sample formatted like the test data so that you manage to answer in a way that passes the evaluation metric. So maybe it's a bit of a boring question to answer, but even if object-level semantics could emerge even from the self-supervision somehow with luck, but you wouldn't be able to let your model reveal that it knows in a way that you can measure on the test set. So anyway, I think that a little finish of supervised, properly labeled data with object-level semantics will be necessary so that you manage to format the answer in a way that you pass the evaluation. So in this sense, we will not. So maybe I'm hallucinating and connecting the previous question to this one, but so the future cannot be purely self-supervised and it cannot be purely emergent. You need to define some coating of your output space at least. So yes, we won't get there totally, I think.
So if I may add something to this, just to point out that this discussion is reminding me of different aspects related to how we humans learn language and the mapping between language and objects, right? The discussion of whether is it by being only exposed to input, right? Or what is the role of interaction? And the interaction would be this kind of additional feedback that you would get in some situations where you have a specific communicative intention and you want to refer to a specific object, and then you might get very specific feedback on this word refers to this specific object, right? And the type of learning that we see in humans combines these two aspects. There is a lot of learning where feedback is not directly present, but then there are a few instances where through conversation and so on, you have this direct feedback, right? And then, so the question is this only providing an additional help? Would you still be able to learn without the interactive aspect? And I think that, well, there is a bit of controversy on what is possible or not, but what is clear, and I think that's obvious to all of you, that obviously you can help your learning process if you provide a few more fine-grained labels like Olga was suggesting, right? And this is not counterintuitive if you think about how we learn.
Okay, so let's move on to the next question. The next question is from Koi. I have a question to ask Dr. Ferrari about the localized narratives dataset. Do you have any statistics on the attributes provided in the datasets? I find there are images where the annotators really give exhaustive descriptions of object occurrences and the attributes, relationships between them. But there are also lots of images that the annotators describe very meagerly. For example, only describe object occurrences like there's X there, there's Y there, Z can be seen on top.
Oh, I have a very precise answer. I recommend checking our own, ECV20 paper, table 3. Out of the 37 words on average there are in a localized narrative, 11 are nouns, 3.6 are pronouns, 1.6 are adjectives, and 4.7 are prepositions or postpositions at position, and 4.2 are verbs. So on average, it's quite rich. Like, if you have 4 verbs and 4 pronouns and 5 positions, it means you have relations between the nouns through these words. But of course, it's not for every image. I encourage you to check the paper, check the table, and decide if you like this data. You can, of course, always filter it because you can measure these things, these linguistic constructs. And instead of keeping all the, say, 700,000 that we release for localized, for open images, for example, you could choose to keep the 300,000 with the most relationship words. You could automatically.
Okay. So Shashank, do you want to ask a question?
Yeah, I want to ask a question to Raquel. So Raquel, thanks for the great talk. Since the data set is in a different language than English, I'm curious to know if there are, if different language evokes a different gaze pattern, especially due to syntactic differences like subject, verb, object, and subject, object, verb.
Right, this is a very interesting question, and it's actually an open question, right? It depends on what is your theory of how much language and vision are aligned, right? So whether, if you take it very strictly, we look at the stuff that we are going to mention right away, then you would expect that there are going to be different if the order, if the ordering of the language is structured differently, that this would impact how you would scan your image, right? And yeah, so there is some evidence that that's the case, but I think that this still needs to be, so cross-linguistic analysis still should be carried out more extensively. So in this case, the dataset is in Dutch, where the word order is a little bit different from English, but not that different. So that comparison might not be the most exciting one. But for example, Ece Takmas, who is the first author of that paper, who is a Turkish speaker, would be very interested in checking what would happen if we had experiments with Turkish, right? But yeah, I would expect to find some differences that are driven by the properties of the language that then are exhibited in differences at the level of the scan path, of the visual scan path.
Okay, yeah, thank you.
Okay, so moving on, we are almost out of time. Let's just take one last question from Madeline. Do you want to unmute yourself and ask the question?
Yeah, sure. I guess I'll ask the last question about something we were talking about a while ago, and I've just been like holding in my head ever since, where we were discussing how ideally it'd be nice if a model was able to learn and look for new information itself, because the language we use is constantly changing, the task, like how you want to use it, is constantly changing. But we also discussed how difficult it is to make an effective evaluation set that actually measures what you want it to measure. And so I was curious, like my first instinct is you just restrict the training set and then have some part of it that's like new in the test set and see what it's able to do. But do you have any thoughts on how to actually, or how to better evaluate the way that VQA models can adapt to new information, especially because the quality of the question and answer is so important, and the like incisiveness of the question, you know? So what are your thoughts on like how we can approach that kind of evaluation? And that's to anyone on the panel.
Can I try to rephrase your question just to make sure that I understand? So are you asking, like, how do we deal with this issue that whatever test data set that we collect, after a while, it will be obsolete because our language is changing, we would need more data sets? Is that the question?
I think that's an interesting question as well. I think more what I'm asking is if an attribute of our model that we want the model to have is that it's able to adapt to new information, how do you test that model's ability to adapt to new information?
Oh, I see.
Yeah.
So I think that my best solution for testing models, it's not really adaptation, it's testing a model in a transfer setting. So I think ideally we want to be able to pre-train our models on a data set that is different and test the models in a zero-shot way without fine-tuning. That at least tells us that how good our representations are without dealing with the fine-tuning confounds. In the fine-tuning regime, the problem I think is that, you know, a lot of the performance comes from the fine-tuning, like the size of the finding data set is important, the set of the fine-tuning experiment is important. So one way to deal with that is just to try to test in a zero-shot way, where you pre-train a model in different data set and then test it without fine-tuning. For adaptation, there are like some work on adaptation, but actually don't have a good answer how you would make sure that you're testing this capacity as the model, like as you require, you know, new data sets.
Maybe I'd advertise here the work of someone else called MAML, meta-learning for a few shot classification. That they really phrased it the way the question came, like, can we build a model which is good because it can be, well, fine-tuned, sorry, which can be fine-tuned to recognize new classes. Of course, the zero-shot scenario is very exciting as well. It tests generality. The MAML was testing how easy it is to adapt, say, let's phrase it like this. And the whole kind of field of meta-learning kind of spewed out. Lots of papers came in that direction. So that's also a line of investigation worth looking at.
Quickly, I know we're out of time, but do you think we'll have to adapt the MAML framework for visual question answering? Like, are there things specific for VQA that might be different than just like learning a new classification method? And if we have to end, it's totally fine. I am just curious.
I'll just do a shameless plug for a paper we did 2-3 years ago. It was called VQA as a meta-learning task, which was exactly that, applying MAML-like algorithm to VQA. So the objective was to train a model that was able to recover information from an external source and try to adapt the model on the fly to a question that was about some topic that was not mentioned in the training set. It kind of worked a little bit, but there's a lot more to be done there.
Yeah, so we are out of time, but Sathik, if you want to ask a quick question to Raquel, feel free to.
Yeah, I found one of Raquel's earlier comments to be very interesting, where she said, hey, we should probably try to learn visual, some of these aspects, visual aspects through communication and dialogue and interaction. So I was hoping in one of her, the photo book data set, she had a game, right? I was wondering if you saw any spurious strategies that come up between these players where they are trying to optimize the objective of the game, which is to identify which of the common image that they have, as opposed to using rich and natural language. Like, for example, one strategy to think of is just list all the 3 images that they have, and the other person can check which image is common. So I was wondering how you instructed the participants to make sure such a thing doesn't happen, and how do we make sure that the language through this interaction is still natural?
Right, yes, thanks for the question. I recall having seen sometimes some kind of strategy where so we allow each participant to play the game a maximum of 5 times, right, with different partners. We actually limited that so that they would not be able to develop a lot of strategies. But some people did kind of develop a little bit of a strategy, and then they would start by telling the other participant who is new at the task by saying, okay, I'm going to tell you what my 3 images are, and then you just tell me whether you have them or not, right? So that modifies a little bit the purpose of the task, but I would say happens in very few cases only. And still you can develop useful interactions because, for instance, there can be a clarification question, right? Even if the speaker just describes the image, it's not a given that with that description, the other one will just be able to say yes or no. Right? So the participants are trying to figure out whether they have matching images. So in general, I think that we got rather decent data in terms of having proper interaction and people trying to coordinate in whether they had the image or not.
Awesome.
Is this what you were after? Yes.
Yeah, it is indeed. Thank you so much for the answer.
Thanks.
And yeah, thanks for accommodating my question, Ayush.
Thank you.
Yeah, so let's end the session here. Thank you all the panelists for the insightful discussions, and thank you all the participants. We would like to remind everyone that we have another panel at 3 p.m. Pacific today, so make sure you don't miss that. And before the second panel, we also have the live QA sessions by the winner challenges, the challenge winners, challenge hosts, and the poster spotlight presenters at noon Pacific today, and another such session at midnight Pacific today. So please check those out too. And lastly, if you haven't already watched the recorded talks, I would encourage you to do so. There's a lot of exciting stuff. That's all for this session. See you later today. Thank you.
Thanks so much. Thanks for organizing. Thanks for having us.
Thank you.
Thanks.
Bye.
Thank you.
Thank you. Bye-bye.
Thank you. Bye.